Okay, we're about 3 after. We'll go ahead and get started here. I'd like to welcome you all this morning to this has ever happened to your plant and other things. Talk about our Odessa event a little bit, what's going on. As you can see here, is probably one of the worst case scenarios you might see if you have windmills, seeing those blades break. You've also probably seen them burning online somewhere, maybe on a YouTube. But we'll talk about looking at predictive ways to predict some of these in the future, using um, analytics, put out by our friends here at Fischer Block. There you go. Again, like to just kind of go through and present our other presenter here, Greg Wolfe. He is the president CEO of Fischer Block. He's been designing and doing electronic widgets and gadgets for years now. Actually, the one he's come up with here that we're going to be talking about is really a neat little product. And then my name is Heacock. I'm the director of NERC compliance here at Certrec. What we're going to go through is give a high-level background on the Odessa event that happened here 2 years in a row, 2021 and 2022. Kind of go over what happened and actually in the end how Fischer Block can tie into that, how Fischer Block and Certrec are working together, and then go into how predictive analytics can help with challenges. Look at use cases. There's a number of that Greg will talk about today. Actually, very good about picking up most of these things. So, really, again, neat device. You can't beat what it's doing from predictive analytics, and then also along with the ease of installation. Excuse me, and then talk about fault recording along for NERC compliance. And we'll go through conclusions and question and answers at the last. I would ask that people do wait for questions and answers, but feel free to put them in the chat box. You can ask those so that they'll be there as you hear it and you don't forget. Feel free to put those in chat and then we'll ask questions at the end. Here at Certrec, we are definitely focused on multiple areas. We're looking at compliance, which we've done for a good number of years since 1988. We've been doing compliance for nuclear industry, and then since NERC came out, we've been working with compliance there. Also looking at SaaS type services and what we can do from handling stuff from a computer instead of y'all loading software on. We can do the SaaS applications here, and then y'all run them just anywhere you need to. Also looking at cybersecurity for utilities and plants and industry. Doing a lot of work with that these days. As everybody knows, there's a lot of attacks from different vectors these days. So we were helping utilities and non-utilities with security. But the big one today really is digitization and how we are handling that information. And again, Fischer Block being a big part of that, that actually will help take information that's analog, digitize it, and then make it available to you as, to help you with various things, in particular, predictive analytics. Again, we want to help the generators be more efficient. Like I said, Fischer Block, they are across the industry. It's not just power, but it's, from generation, it's transmission and distribution and also industry. The nice thing about Fischer Block is that it can actually look at what's going on with the motor. It does analytics based on the signatures from the current and voltage, and it'll help you determine if you need to do preventive maintenance way before the motor / pump destroys itself, say. Worst case, going back to our initial opening of the broken blade on that wind turbine. So kind of mentioned this at the beginning, Odessa disturbances, there were two of them. One in 2021 and then also in 2022. The main reason why they called the Odessa disturbance is because they had transmission line issues in the Odessa area of Texas that caused major large-scale outages from inverter-based resources due to the type of faults and the issues with the inverters not necessarily not responding correctly, but maybe over responding to some degree. As you can see, in 2021, they lost a little over 1,000 megawatts of inverter-based resources, primarily solar type. And then also in 2022, the number was up a little bit, from 1,100 to 1,700 megawatts. So a lot of disturbance issues, and this is what definitely got NERC's and ERCOT's attention during these events. So that was a lot of power lost at one time. And reason why NERC is doing it because we need to have a reliable grid. It also caused in 22 event, we caused the loss of 844 megawatts of synchronous generation, and we'll show you where those were at on the map. So it's not just causing problems with IBRs, but also with our normal synchronous generation steam plants, combustion turbine types. So it can affect others besides just the IBRs. With the event, they did notice that there were 10 different inverter manufacturers that were affected in 2022. They actually had about the same number in 2021, but the interesting part was that 3 manufacturers had the major portion affected both times. It's not like they weren't trying to do something. They actually did work forward and try to reduce these effects. This may not have just gotten them all, but they show which ones they are down there: Power Electronics, CAISO, and TMEIC. So both of them had large scale. The one that reduced was CAISO actually did some changes and made their population in 2022 a little less due to some of their changes. But of course, the manufacturer and the folks that own these inverters are doing work to try to lessen the effects. For, again, the event, you can see the big blue dot is basically where the event was, of course, right there about Odessa. And then you can see the size of the bubble shows the size of the impact of loss of generation in the areas. You can see way down South Texas, there was due to the disturbance that actually tripped a synchronous unit down south. The blue is the synchronous and the reds are the IBRs. And you can see how close they were all to Odessa. So closer in, typically you have a greater effect, especially with voltage issues. And that's really what happened in this particular event, is that there's a lightning arrestor in the 2022 event that failed, causing a low voltage on one of the phases. And as a result, the IBRs, as fast as they are, will try to bring that voltage back up to be where it needs to be. And when the fault was cleared within a few cycles, voltage on the grid was restored to normal. However, the inverters were not necessarily quick enough to bring that voltage back down as output from the inverter. And it may have tripped on over voltage, but there was also some other events too. There was some instability on those phase lock issues. So there's a number of items that cause these inverters to trip, and they're still working through all those items. But you can see it was pretty large scale and not necessarily right up next to where the fault occurred itself. The Odessa, mainly the Odessa areas, but then definitely a few way down south. So with electricity, nothing's necessarily localized. When you have an issue on a grid, it can ring out to further than just the local area itself. So as part of all this, NERC has put together a new project for it. It's the 2021-04, and they put out a standard authorization, a request out to make enhancements to PRC2. And they'll also be working on some PRC24 items for ride-through. But the one we're kind of interested in, mainly with Fischer Block PRC2, is the one where they do looking at recording the grid items, in this case, fault or sequence of events, and then also dynamic disturbance recording. So their long-term plans is make sure that plants do have a high-level resolution oscillography data recording. Plant cicada also recording if they have that. Inverter level sequence of events recording, having fault codes, as part of that. And then also make sure the data is available at the BE resources so that they can actually provide this to others. And this actually is one of the main recommendations out of the standard, and actually review the event that was put out by NERC back in December. They basically said we need to have plants have this oscillography recording capability, which really gets right back to why we're here and talking today, is that this can be easily done with the Fischer Block. It is definitely a nice little device. And with that, I'm going to start letting Greg talk about this. He's probably bored of me hearing that, so we'll let somebody else say something.
Thanks, Evans. Really appreciate the opportunity to talk about our solution and what we see in the market and some of the challenges we're helping our customers overcome. What we're seeing here, though, is basically a high-level view of our platform, which is comprised of both hardware sensors, which we call smart blocks there on the left, about the size of an iPhone, a couple inches thick. And that device installs in various locations on the grid from generation through all the delivery, transmission, distribution, and then in high consumption plants. And it's doing 24/7 monitoring of the electrical signals, voltages, and currents. We have implementations where we're also monitoring temperatures and even vibrations and speeds of shafts and rotating equipment. But that device is intelligent enough to ascertain when things are getting out of the norm. And when those conditions arise, that device then will capture the electrical signatures and send them off to the software platform WaveIQ, which then does further analysis, compares signatures against historical norms, either for that particular device that sent in the file, or against sister devices, data files, and histories, and then presents that information in terms of actionable insights on various dashboards. There's communication alert notifications as well. And the whole idea of the platform then is to monitor 24/7 and not only capture waveforms when a breaker trips, but really focusing on conditions that are out of the norm that may be indicative of degradation of assets in the system, so that preventative action can be planned in a coordinated way to save on time and costs, avoid costly outages, provide visibility, and those types of things. So very happy to be able to share some of the use cases today with the group. So this is kind of a breakout view of a wind turbine drivetrain. Actually, the blades there would normally be there on the left. That's that part of the system is rotating at about 1/4 hertz, so once every 3 or 4 seconds. And then as the energy is transmitted down to the generator there at the right, it goes through a gearbox, and so there's various stages of gears all rotating at various frequencies, and the highest frequency of rotation is on the very right as it goes into the generator. Depending on how many pole pairs in the generator, that generator will be spinning at maybe 1,200 RPMs, 1,800 RPMs. And so those frequencies of rotation of the various balls in the bearings, the bearing races themselves, the various gears, as those components degrade, they actually begin to distort the electrical signal coming out of the generator at the frequencies that those components operate. So a gear tooth mesh that's meshing at, say, 200 hertz, 200 times a second, well, if that tooth starts wearing and degrading, then we will see a 200 hertz distortion in the electrical signature and signal. And so our platform then is continually extracting all the frequency elements out of the electrical signal, out of the 60 hertz signal, and we track the frequencies of the various components, both electrical and mechanical components. As they degrade, will affect the signal. So we then have a red, yellow, green type of intuitive dashboard so that users can very quickly see what's degrading and how bad, what severity is degradation is observed, and plan action, as I said earlier.
And just real quick on that too, there's not going to be really any difference between a drivetrain for a windmill as compared to, say, a motor driving a pump. There's similarities there to give you the same sort of a signature back, correct?
That's right. It's interesting. A motor's consuming current, where a generator is putting out voltage and current, and the direction of the electrons is in the opposite direction. However, it doesn't really matter which direction the electrons are flowing. The distortions at various frequencies manifest identically. It's basically the flux across from the stator to the rotor, and that flux gets distorted and it shows up in the signal. So yes, and both mechanical and electrical elements of the system affect the electrical signal. So many times when we're measuring vibration with our vibration sensors on a piece of rotating equipment, we'll be able to correlate with high correlation between the vibration signal and the electrical signal and see the same frequency distortions. But those faults that don't vibrate, basically we then can pick up in the electrical signal where vibration plot, would not. So it's interesting to see electrical and mechanical component degradations show up in the electrical signal. So yeah, I mean, this is kind of, I think, the opening paragraph to one of the reports that you were talking about earlier, Evans, where
Yep.
The governing bodies are recommending that high resolution oscillography be installed or capable of capturing devices or signals at these various inverter-based resource plants, whether it's wind or solar or what have you, so that if there is an event out on the grid and the IBR plant goes offline, that there's a waveform capture so that diagnostics analysis can be carried out in order to implement corrective actions. And so not only when the plant goes offline, but when there's events out on the grid and the plant does not go offline, if you have a system like ours that's doing 24/7 recording, then the owner operators of those plants will know what margin their plant had. Did it almost go offline, or was it sufficient margin where they're covered so that they can
they can go
sleep
back
well
to
at night. There's confidence that it's meeting the standards. So yeah,
right.
that's a big part of what we do.
Back to the regulator or the ISO in this case that say that we're okay and we can prove that we're okay. So yeah, it saves money, either from trying to figure out what your problem is or show that you're fine and have the margin like you just said. That's very important.
Correct. Yeah. And so this is on an implementation at a solar farm. I just happened to be at the solar farm this week, yesterday and the day prior, and it's interesting because some people say, well, what is there really to measure on a solar farm? It's all DC, just flat line voltages and currents. However, it's very interesting when you do the high resolution monitoring, the frequency distortions that exist on a solar farm and near the inverter with the harmonic distortions and even ground faults. They happen very quickly. Those are transitory events. And without any type of high resolution monitoring, it can be very difficult to get to the source of a ground fault. Some of these technicians have to walk miles physically looking for and doing portable tests to find a ground fault. And so being able to put current sensors down in the combiner lines and the recombiners, we typically can get within a few hundred feet of a ground fault and save, a couple, 3 days of diagnostic time if there is a problem, and even then provide some predictive analytics as well if things are getting worse. And the same device, we call it a smart block, that we just saw there on the solar farm, also has applicability across the grid. This happens to be a distribution substation. This particular implementation, we used a variant of our device that actually becomes a retrofit cover to a flexi style test switch. And for those on the call today that are familiar with substation architectures, nearly every control panel on the grid, even in industrial plants and on wind farms and solar farms in the local substation, have banks of test switches that you can see underneath our devices there. That third panel from the left does not have one of our devices, but you can see that that plastic cover that covers the test switch. The test switch is there in order to run periodic testing on the relay, whether it's a microprocessor relay or electromechanical relay in this case. Those relays are doing 24/7 monitoring of the electrical signals on the grid, and when things get to a point where there's an unsafe condition out on the grid, maybe a down power line, that the relay will trip the breaker. And if it's a electromechanical relay, you have no waveform to look at in order to determine why did the breaker trip? Was it a malfunctioning relay? And so forth. So in this case, we're providing visibility to the customer in terms of when a breaker does trip. However, in this case, our utility customer was getting numerous nuisance trips whereby one breaker would trip and then it would cause flickers and maybe other breaker trips on other buses and feeders. And so we installed 40 devices as retrofit covers on those test switches. So no wiring. We just have spring-loaded pins underneath, doing all the voltage monitoring, just with 2 thumb screw replacement of a cover. No outage install here. So in one day, we installed 40 devices, and then within 10 days, I think they had their first event where we now have provided them a 40 waveform sequence of events capture. And so you just scroll down, all 40 waveforms are on one time axis, and provided them the visibility and the information they needed to do the diagnostic analysis. Now we're providing predictive analytics in these stations as well.
So really and here's be part of the example is that this is the ease of installation is what you just said. You can actually install them in a day compared to a digital fault recorder of old that you're not actually having to wire into a digital fault recorder. You're just actually pulling straight off of the pins. And then also you'll describe some of this for the CT circuits, the current circuits, but you have essentially no wiring.
That's right. We, in addition to picking up voltage with our ruggedized pins underneath our device on the front of the panel, we also, during the install, will replace one of the mounting bolts on the Flexi test switch, and we insert one of our, what we call smart bolts. It's hollowed out, and we run an insulated tube right through the bolt. It's the same thread as the original bolt, 1032. So you can still put the old cover back on if you ever need to, but right there through the mounting bolt, then we have the insulated cable coming through to the back, and we terminate that with a connector that mates with a 3-phase split core revenue grade CT probe assembly. We just snap them together, lays in the tray. And so in about 10 minutes, then we're monitoring 3-phase volts and current. We come through the other mounting bolt with a Ethernet cable, actually a little miniature insulated cable goes through the other mounting bolt, and we terminate that with an RJ45 connector. We've even done some fiber optic installations. And so we communicate through to the server, power the device, PoE, over Ethernet cable right through the mounting bolt. We can also power off phase voltage as well, and then provide the visibility very quickly and without an outage, without any new wiring.
All I can say is I wish you would have had this out sooner when I was in the industry, Greg. I would have snapped a bunch of these up. We were always doing either DFRs or having to put in portable type recorders, that would do record the fast Fourier analysis type for signatures like you're doing now with a small
right
snap-on,
well,
almost snap-on smart block there.
Right. Well, we didn't invent this until 2016 timeframe. Our team is from the portable world, designing relay test equipment, power quality instruments, battery testers, even Flexi style test switches. And so we launched the product 2018 timeframe. We were getting real good momentum. Then the COVID pause, and now we're busier than ever. So, but the people in the industry now that are benefiting, they're happy they have it for sure.
Oh yeah.
So, yeah. And this is an example here of a large motor. We're monitoring 24/7 current consumption as well as the voltages, and that top right frequency spectrum there, you can see those side bands. The fundamental there is in the center at 60 hertz, and as rotor joints degrade and become hot spots before they begin to even crack or have any type of vibration associated, we will see the distortion in the 60 hertz signal, and it actually manifests as side bands. The distance from 60 is a function of the slip frequency, so the rotational speed of the motor versus the grid's running at 3,600 RPMs, which is 60 hertz. Motor will be a little bit slower than that, and that difference is the slip. So we know where to look on the frequency spectrum, but in that case there, it's quite obvious that those sidebands are due to some type of a distortion. And those sidebands will actually grow in height. And as those joints degrade, if the height of those sidebands finally hits a threshold, it becomes like a yellow versus a green, and then it becomes red. And then we alert the operators through the dashboard or even email or however they have set up for their alert notifications. And what's important here also is the noise floor. So the more dynamic range your system has, so a system like ours that can sense very subtle changes or distortions as compared to the main signal, that's what determines the noise floor. And so if the noise floor is low, then you can see these sidebands begin to grow much earlier. You get many more weeks and months notice before you have to plan an inspection. And so we're proud of the noise floor we have, 100 dB range. We've seen other systems at 60 dB, so we provide a number of months additional notice to our customer base. And this is an interesting use case whereby in the frequency spectrum there, we see and observed distortions at multiples of motor speed. And that's typically a classic signature of a imbalance in the shaft. And so that's what we alerted on at that time. This was a few years ago. When they went in and did the inspection, they actually found a pinched rotor cable that was arcing at a frequency associated with generator speed. And that now has become a warning sign. If we see this type of a signature, it may be an imbalance, but it may be some type of pinched cable. And so it's very important, and it really helps the learning of the whole system is when a repair is undertaken, that the results and the inspections, that is fed back into Wave IQ so that not only will that customer, but those teams benefit going forward, but any of our customers that are on the program will be able to leverage that learning as well. So there's automated learning with the AI and the algorithms, but there's also learning from what the technicians find during inspections and engineers find during analysis. That all gets fed back in. And then this is very similar. You talked about a lightning arrestor out on the grid problem that was, I think, part of one of the Odessa events. So this is an indication of a capacitor switch bank controller whereby our platform doing high resolution continuous monitoring was able to determine that the capacitor banks were not being switched in and out at zero crossings, which is the intent of a switch bank controller. The timing was degrading in the controller, and capacitors were being switched in and out at points that were not near zero crossings. Therefore, quite a bit of arcing was going on, and that manifests itself in the electrical signals there. And so we were able to provide advanced notice of a problem there to avoid an outage. And then, lightning arrestor here. So for several hours, days prior to an arrestor failure, we can capture then transients, not just at the waveform level, but actually in the RMS. They're severe enough in many cases to manifest, because the RMS signal is typically measured over several cycles. And so transients sometimes can slip through an RMS signal, like in SCADA, a lot of times will not pick up any type of transients. Whereas a high resolution waveform monitor would. And so in this case, it was severe enough towards the end where RMS signal was quite distorted there with those spikes in that signal. And then the zoomed in view of the waveform upon breaker trip is in the bottom there. And interestingly, it took about 30 cycles to clear. So that was an issue where the relay now is being looked at for malfunction. And then those snippets there in white, those little ovals, those are from a an IEEE report talking about lightning arrestor failures, and we've included them on the slide to show the similarities in some of the captures our platform has done within WaveIQ.
So just real quick, you've kind of brought up sampling rates. Talked about it and how you sample. What is the sampling rate of the Fischer blocks? How fast do they sample?
Well, it's a good question, because most people believe that the higher the sample rate, the better. And in certain applications, that's true. And in this case, out on the grid, 128 samples a cycle is our typical sample rate. If you sample faster than that, in many cases, you just end up with more data than you need to analyze the problem. But 128 samples a cycle has been sufficient for the predictive analytics and the waveform capture during breaker trip out on the grid. For asset monitoring, rotating equipment, whether it's generation, wind turbine, or fossil fuel or hydro, and even in industrial plants, rotating equipment motors, if you sample at a slower rate, then you're able to sample for longer durations. So your sample set data, the number of samples is the same. It just took longer to collect them because you're sampling at a slower rate. Well, that longer duration sampling is what dictates the resolution on the frequency spectrum. And so the longer duration, you can get a much higher resolution. So you can get 0.001 hertz resolution on the frequency spectrum if you sample for long enough. So in those cases, we will actually vary our sample rates. So we'll do some sample sets at high sample rates for shorter durations, and then kind of midpoints, and then slow sample rates for longer durations. And then we can get the resolution, and then get the high frequency analysis as well. So we vary our sample rates based on application. Good question. Recently, we launched this application. It's a module within WaveIQ, whereby we are feeding live video feeds directly into our software platform. And we're working with some customers now to build up our fault signature libraries associated with hotspots and arcing, whether it's in a substation or out in the rural areas where tree branches are on the lines. And WaveIQ then is doing object detection on the video feed, and we're training that to sense these arcs and hotspots. And when those conditions are sensed in the video feed, WaveIQ will synchronously trigger our smart blocks to capture electrical signals at the local substations, and so that we're able to now build our pre-trip event libraries, electrical signature libraries at an accelerated rate. We don't have to wait for breaker trip to get a signature to put in the library. So we're building our libraries now for this application such that our platform can then sense and predict that arcing and hotspots are happening in areas where we don't have a video feed. And so it's very exciting for us to be working on this technology, and we're working with some utilities that are dealing with wildfire issues and arcing issues and hotspots and substations for predictive analytics. So I guess I'll turn it back over to you, Evans. But yeah, the ease of install is where we started as a company. The retrofit cover on the Flexi test switch was our flagship initial product to market. However, the last several years, the focus has really been on predictive analytics. And so we learned that if you install a platform very quickly and efficiently, while that does provide benefits, and significant benefits in some cases, if you don't have the high sample rates in the cases you need it, and the revenue grade accuracies and the predictive analytics, then you're really missing out on the benefits. So we've really been focused on WaveIQ for the past several years, and we think we have industry leading applications and algorithms in that regard. So we're very excited to be able to talk about our platform today with the group.
Now, I think definitely with the ease of installation, I'll go back to when I was working at plants and other places. I really do wish we had something like this, because it is very easy to install, and then the predictive analytics that go with it are tremendous. So you get two in one. Not only are you seeing what's going on, you can look at it any time. Say if you call up the instrument and say, okay, what is my pump doing, or what's my power system doing? You can look at it real quick, get some quick feedback, but also it's tracking, and the predictive analytics will help you out in the long term. So from a standpoint of a plant operations, from a maintenance standpoint, it's a heck of a tool also, because it can help predict what's going on. If you're looking at these things with the alarms that come off the Wave IQ, you get that fed back to the plant personnel, maintenance, engineering, whoever it might be looking at all this. I mean, all that information is really good. It's not, and it's focused to what you're looking for, not necessarily bombarding you with tons of information, but you're looking for those specific spikes, when they occur based on the Wave IQ feedback and what they've learned. So yeah, a lot of folks are going to predictive analytics out in the plants. You can help out tremendously with maintenance. Go ahead.
One thing I'd like to add here on this slide, Evans, is it seems like, for obvious reasons, there's a growing focus in industry on capacity planning. With more and more wind farms that are being produced and solar farms coming onto the grid, load profiling, capacity planning, that's becoming a growing area of focus, in addition to predictive analytics for asset degradation. And so many of our implementations, our devices are streaming DMP3 directly into SCADA systems for load profiling. And in parallel with that, the high resolution waveform data streams into Wave IQ that's accessible through the Certrec portal provides predictive analytics. So it's interesting to see how the market is changing in that regard. We're able to support those areas.
Yeah, no, that's a very good point, because yes, you're right. Things change pretty quickly on the grid, especially with solar, if you have a cloud or something. So having that information come in, and they being the operators, whoever that might be, either at the owner level or at the ISO level, pull all that information in so they can definitely know where they need to go for power and change power requirements out. So yeah, that's a very good point. And like you said,
and EV chargers.
Yeah. There you go.
Automobile.
Even more so nowadays, right? Since a lot of those are coming
exactly.
online.
Yeah.
More and more electrical. So one of the things we did talk about early on, and actually with the Odessa event, we're talking about the NERC going forward, and right now saying that they do need to make sure facilities do have the ability to record this information. Oscillography is a really big part of understanding what's going on when you have problems. So you want to make sure you have those things in, and then as part of that, it helps meet the PRC2 requirements for disturbance monitoring. It's just so many things I can't even begin. Greg's given a lot of examples of what it is. Not only is it good for a standpoint of making sure your plant's doing what's supposed to be, from a solar battery, or even a wind, and even existing synchronous type generators, but it's also good just from standpoint of predictive analytics. But we can help meet the requirements PRC2 and VAR2, which is making sure the appropriate voltages are coming out of the plant, that you're tracking, that your inverters are all tracking, wind generation is tracking where it needs to be from a voltage output standpoint. So from a compliance standpoint, it's also very, very, very useful for that standpoint also. So going back through it, really what Greg has talked about is definitely improving your return on investment. If you have predictive analytics with using this information, you can actually get out ahead of your maintenance items before your plant breaks down. You can see stuff. You get out there, take it offline, do what you need to so you don't lose production. If you're at a industrial facility or some sort of manufacturing facility, you can take it offline, fix it, and get things back in without losing product time. You can do it wisely at the right time. Actually, same sort of idea with your generation of any kind. Hence enhances the reliability because you can see what's going on visibly. You can get out ahead of it with predictive analytics. Does help with compliance and reducing your risk from a NERC standpoint. And then going forward, how can we help you? Get out there. Let us know how you want us to help us. Let's talk with you guys. Get in touch with us. We'll be happy to spend the time and tell you how it can be used. You can use small amounts, or deck out your whole system depending on what you have. It's really going to be up to you. But talk to us. Let us know what your needs are, and we can help you out there. So going to that, we go to some. If anybody has questions, right now you can go ask them. Come off mute and ask, or type them into the message. I don't know if we have any, Brandon. Do you see any questions?
I don't see any just yet.
Okay. So I don't know if you've ever seen, Greg, anybody sitting up there like that, taking it easy on top of a windmill. I don't think I could do that, but
I have many times.
So
I personally don't go up top. I'll stick my head out because I'm usually doing work when I do go up tower. But yeah, many techs will just go right out and stand out there and look around. I prefer not to do that.
so from a standpoint of the overall reliability of your device, how reliable do you say your device is, as your history that you've had
Well, it's
so far?
interesting because the our design team is really largely from the portable instrument world, test and measurement. And in portable equipment, that equipment has to provide the electrical signal and record it, because typically portable equipment is performed. Those tests are performed in an offline environment, typically either periodic test or diagnostic. So things are offline and isolated, and the test equipment has to put out the signal and record the response. And putting out the signal requires another level of complexity as compared to just measuring the signal. And so what we're doing, online monitoring, we're not generating the signal, we're purely monitoring. And it's really, when we're monitoring voltage, it's microamps. And when we're monitoring current, it's the, we're measuring the magnetic field around the wires with CTs. And so we're dealing with extremely low signals. And therefore, our components inside our device are not being stressed as they would if we were dealing with high currents. And so we've had really single-digit returns in several years. We really do not have a reliability problem, although we have a robust warranty program. But yeah, that's one of the things we're proud of is our quality history.
Okay, so we got a question. Does your data format comply with any industry standards?
Good question. Our as I mentioned during the discussion today, we have actually a dual data stream. One is a DMP3 industry protocol directly into third-party SCADA systems, which can be RS-485 twisted pair, or Ethernet, or Wi-Fi, or fiber TCP/IP communication. The data format for the high-resolution waveform captures is in a proprietary format coming out of our device, the smart block. But as soon as that data file hits the WaveIQ server application, the first thing WaveIQ does is convert that data file to industry standard formats. Comtrade is the most common that our customers configure the application for. And then those data files are what WaveIQ does all its analytics on, the Comtrade industry format version of the data file. And those can then be made available to third-party systems in many different ways. API hooks into our database or through folder structure. And then some of our customers actually use other third-party equipment that's not Comtrade compatible, and we have data formats for that as well.
Okay, so if we kind of talked about helping folks out. Say if somebody wanted to do a pilot, what have you seen so far? I'm assuming you probably have had some folks looking at pilots. What would you say a pilot system would look like?
Well, that's a great question as well, because nearly every customer account we have started with a pilot, so that they could get comfortable with, what do the data streams look like, what type of value and resolution and so forth, what type of insights can be gleaned. And so we have, based on the application, whether it's wind turbines in this case, or industrial plant or grid application or solar. We have various pilot programs, kind of like smart start programs, and many times we'll use embedded cell modem versions of our products so that we don't have to connect to the customer's network, which adds additional layers of decisions and time. If we have to connect to the customer's network, that's not a problem either. We do pilots where we connect to the network and we have WaveIQ running on the customer's network. But sometimes pilots will do a cell modem within our device and stream that data directly to our cloud platform, and your Certrec portal as well. And so really the pilots in a lot of cases are designed to make the communication as efficient as possible based on the customer's environment and architecture. And so we typically have very efficient pilot programs where we come in one day, install 8 or so devices, and we're typically getting data same day. And within 30 days, the value is typically shown itself to where within the first year it pays for itself. That's the goal of our commercial model and our technology.
So just real quick too, one of the things you and I have talked about here recently was SIP 13. How does the Fischer block fit into a SIP 13 procurement cycle, would you say?
Right, that's interesting because in some of these SIP 13 controlled environments, medium impact stations, that question comes up, like, well, what about the data security and so forth? And what's interesting is our device, while it's high resolution waveform capture, it has no ability to control anything. There's no outputs on our device that are connected to any control equipment. So if any malicious entity were to hack into our network, which is a different network than the customer's network, if they were to hack in and somehow take control of our devices, which has not happened to date that we know of, but if they were able to do that, they could not, it would be physically impossible to trip a breaker or control any equipment. So it's really, our platform is exempt from SIP 13. It's on one of the if you look at the list of applicable equipment, any equipment that does monitoring, if it does not have control ability, then it's exempt. But having said that, all of our procedures in terms of software control, vulnerability control, notification management, patch management, all do comply with SIP 13. And so even if our device were to be included and it was not exempt, we would be compliant regardless. So that's our approach.
Okay. For the data that comes out of there, where does the data reside initially and in the end?
Our device, the smart blocks themselves do not store data. They store data in a buffer long enough to send it to the server. If the server's busy on another task, our device will wait until it finally sends the data out. Some of our customers choose to have a data concentrator local in the station, and users can access the WaveIQ portal there. We have other implementations where we stream directly to a remote server, which can be on the customer's network. It can be on our cloud network, either on Amazon or in our facility, servers in our physical facility, or to the Certrec portal where data can be accessed there.
Yeah, and all these are, especially including the Certrec, we actually are our data is at a FedRAMP, which is secured data stays in the U.S. With information is, like you said, in transit and at rest is encrypted, so it keeps people out per se. So not had any issues with that. All right. Mm-hmm. Any other questions come from anybody? Anybody want to ask a question? All right. I guess not hear anything more. I do appreciate your time today, Greg. Very informative. Again, like I said, I've definitely wish this was around when I was in the business more, having to build these things and pull that information in. It would have it's a heck of a product, and ease of installation is just incredible. Anyway, I'd like to let you know, as you can see here on the screen here, you can get in touch with us. Visit our Certrec.com reliable power. Set up a consultation and get back with you on this. You can see your phone numbers there too. If you need to call us, feel free and get in touch with us. We'll get back in touch with you. It's a great product. When I first heard about this, I was really, really excited about it, and still very excited about it. And the combination of things, predictive analytics and the just the ability to record information is just tremendous. So get back in touch with us.